Okay, ladies and gents, we're in the familiar setting of my living room, and in order to just give today's lesson a nice tiny start, I want to set out what the point is. Um, there's quite a long video for you guys to watch. This is normally a session that I would do outside with DP1s in order to prepare them a little bit for the IA, and in order to go through the main set of soil sampling measurements that I would expect you guys to at least consider using in the IA if you do an IA based on soil. Now, you guys are going to need to watch this through. That's going to take up the first period today. I'm probably going to say that a lot during the video. Take a break, and then the second period will be time for you guys to do a little bit of work. There's basically a question sheet that follows this. So, very good luck today, chaps. Myself and your ESS teachers will be on the team chat, I'm sure, or in other ways available for any questions that you have. And if an IA question already pops up in your mind, please don't hesitate to get in touch and ask us, or if you've had a great idea, because this really should build on the work that we did when we went away together for our windy holiday in High and Boycott. Now, chaps, good luck with the work today, and we'll see you not next week, but the week after. But we'll see you next week anyway, online, but actually in person. Deeply exciting. Farewell. Okay, so ladies and gents, I don't know how many of you are like massive House and Down fans, but my wife certainly is. And every week there's this sort of uncomfortable section where Aveline records what she's doing from her garden. And every week I look at her and think, I'm sure I could get better production values than that. This week we'll find out if it's true or not. And a heads up is, I don't think it is. However, welcome to the garden. There are birds, there are clouds, and there's wind, which I guess proves that we're outside. What we're going to do today is I'm going to take you through a few soil testing techniques that are going to be relevant for your coming internal assessment. And I'm also going to go through the rationale for planning, I guess we could say, a mini IA in my back garden. So, the first thing that we have, the sun came out. Sweet. Good thing I put no sunscreen on. The first thing that we have is we have a schematic map of my garden showing the most significant features. Now, if you're interested, the house is here. Outside the house is the garden doors. We have a patio which stretches across, with dining table on it. But this area in any case is paved. We have here a little sort of extension bit, I guess, of like gravel and stuff. It's the pathway that comes around the side of the house. Now, this whole section here, across this bit and that, this is all lawn, okay? So this is all grassed area. And then at the back, we have an area that's set aside to be a flower bed, and it's got some plants and stuff in it at the moment. I feel it necessary to excuse some of the parts of my garden since we're in the process of tidying it up. It was all paved this time 3 months ago, so significant work has happened. Now, let's get stuck in. Since we're in the soil topic, then it makes sense that we're going to look at soil. And there are three factors that I want to mention today in class as we go. The first of those is pH. The second of those is moisture. Good job I didn't leave myself enough space. So we've got pH, we've got moisture, and the third of those is soil stratification. Tragic. Didn't leave enough space for any of it. But so it goes. It all fits nicely on there, okay? These are three things that you can very easily investigate when you look at the soil. And each one of those has kind of reasonable things that you could expect to make a difference. So for instance, let's do a little bit of pointerizing. Around my lawn, we have a patio, we have a hedge, and inset into my lawn, we have a tree. Now, each of those things could make a difference to the moisture, to the soil moisture of the lawn. For instance, underneath my patio, or underneath every paved area, is compacted sand and rocks. Now, that area of compacted sand and rocks makes for amazing drainage. That's one of the main reasons it's there, as well as to provide a stable base for whatever you're paving on top of it. Well, it means that drainage here, around the edge of the lawn, is much, much better than it is in the centre, because any water that infiltrates here into the grass and into the soil underneath can drain away through the patio and underneath the house and off. That's the reason that you guys, if you have a look under your floors, we all have sand in our foundations. It helps the bottoms of our house to drain out, especially after wet winters like we've had at the moment, or like we've had this last year, I should say, sorry. Next up, we have our hibiscus tree. Well, the hibiscus tree requires a lot more water and a lot more nutrients than the grass around it. So I have to be extra specially careful that this is the canopy drawn on, that this area around the hibiscus tree gets a little bit more water and a little bit more nutrients than the rest of the grass. I also know, because my background as a biologist, that when a tree wants to absorb nutrients from the soil, that it helps that process to happen faster by pumping hydrogen ions out into the soil, and those hydrogen ions in essence are acid particles. So the soil in principle should be more acidic around the base of the tree than and it should become less and less and less acidic moving out. The last factor, and the factor that I think I'm going to investigate first, is the hedge. Now, the hedge that we have around the edge of my garden is a hader hedge or an ivy hedge. Now, it's super fast growing, and that's which means it absorbs a lot of water and a lot of nutrients from the soil. I'd expect, therefore, for the hedge to have a drying effect on the lawn, and I know that if I don't water the lawn too often, that it starts to brown up just along the bottom of the hedge here, and it gets kind of greener and greener and greener and greener the further away from the hedge we go. So, the first thing that we're going to do is we're going to model how I would run a dip test, in essence, a dip test IA. Now, for this instance, I've made myself a fake soil moisture meter. You can see it's on like a satay stick, and I've made myself a fake soil pH meter. These obviously are amazing. Let's just agree on that before we go any further. And I'm going to use these to pretend to stick into the grass and measure the soil pH, or the soil moisture level. Now, if I wanted to look at the impact that the hedge had on the soil moisture, what I would do is I would plot what's called a transect. Now, this is my hedge over here, and this is where the roots of the hedge grow. A transect is where you move in steps away from the factor you're investigating and take measurements. So, if I move out in a line in this direction, then I would expect the influence of the hedge at the start to be the greatest and at the end to be the lowest. And maybe I could take a measurement at 0, at 0.5, at 1, at 1.5, at 2, and at 2.5 meters from the hedge. Now you'll notice that I've put down 5 values. And it's super important that when you do a transect you take 5 values, because the end game for a transect is a graph where you plot soil moisture, an average soil moisture with standard deviations attached to it, moisture and distance, and you draw a nice line of best fit. That's where we're moving towards, okay? Now, when we're doing a transect, we need to do not only 1, not only 2, or 3, or 4, but 5 transects. We need to take 5 transects away from our hedge. And in each transect, we measure the soil moisture at these different distances. We could just as well do the same with the soil pH. We would expect the soil pH to become lower the closer we move to the hedge. So that's approach number 1 that we're going to take, or dip sampling. Approach number 2 that we're going to take is a little bit different, and it's going to be based around soil stratification. So what I'm going to need to do is I'm going to need to turn over, I'm going to need to find myself a brand new fresh page, and we're going to go through the whole process again. Garden, patio, playhouse with slide, a flower bed, path, tree with canopy, table with chairs. I'm sat on that chair right now, it's very exciting. Hedge, running each way around. Okay, happy days. Now people, next up is an amazing way of doing your IA for those of you who don't adore mathematics. And this is the area comparison. So rather than looking for the impact of a hedge, what we're going to do is we're going to look for the impact of the lawn. So this is my lawn, my grassy area, okay? And I want to know the impact of the lawn on soil moisture. Let's do soil moisture for this one as well, because it keeps it nice and straightforward. Now, I have area 1, okay? And area 1 is my flower bed at the back. I have area 2, and that is my lawn space. Now, very simply, if I want to compare the moisture in area number 1 to the moisture in area number 2, all that I need to do is I need to appropriately choose 25 points in each space and measure them. Now, life can't get much easier than this, okay? Because simply, we measure across. Now I know that this is 2 meters across, 2 meters deep, and I know that it's 5 meters wide, okay? So, I make myself coordinates, 0, 1, and 2, 0, 1, 2, 3, 4, and 5. And, using a random number generator, I generate coordinates. So maybe my first random pair of numbers is 2, 1. Put an X there at 2, 1. My next set of coordinates is at 2, 2. My next set of coordinates is at 4, 0. My next set of coordinates is at 0, 2. My next set of coordinates is at 1, 1. This is fairly straightforward. I keep on putting X's down. All that I then need to do is go and visit the flower bed, take my soil moisture meter, stick it in the ground, and read off the soil moisture number that comes off at each of those coordinates in turn until I have 25 numbers in a row. I then do the same for my second area. Now the lawn's a little bit bigger, so maybe I can get 0, 1, 2, 3, 4, and 5. 0, 1, 2, 3, 4, and 5. But again, it's as simple as marking off my coordinates that I generate using a random number generator, which will allow me to come up with 25 measurements of soil moisture. At the very end, I calculate an average for each space. I calculate a standard deviation for each space, and I graph the average moisture level in the two different spaces with moisture versus, and then let's make this lawn and flower bed with an appropriate title. This allows me to, this allows me to see what the difference is between the soil moisture in the lawn and the flower bed. It allows me to see what impact grass has on my soil moisture, and this is actually quite an interesting investigation, right? Because I had to choose what I should do with my garden. When we bought the house, it was a mixture of being like patio, so being paved with big paving stones, and then the rest was kind of under gravel with little tiny flower beds inset, and it was quite pretty, but it wasn't really to our taste. We wanted somewhere with grass so that our son could play out and roll around and, you know, be a horrible dirty little boy, which is what I think small boys like to do, at least from my own experience it was. No, we've done that, and I also thought to myself, well, soil biodiversity is improved by keeping a lawn. It reduces chances of localised flooding if you've got a lawn. That's a good thing, especially with the water management problems we're going to have in the Netherlands for the coming years. It should, in principle, improve soil organic matter, which improves water retention, so it should make the soil maybe a bit less drought resistant. If I want to keep it pretty, however, then it's going to need to, I'm going to need to water it. I'm going to need to water it through the summer, so that's probably a negative ecological impact of me having a lawn. It grows a lot, it grows a huge amount, so I need to cut it. That biomass is captured and goes into the green bin. Well, I guess it's a form of carbon storage. You can view it that way. If I'm producing larger amounts of biomass in my back garden than I ordinarily would do. Now, what we're going to do is we are going to stop this video right now. I'm going to move over, and then we're going to go through the practicalities of a random area sample versus a transect, dip sampling like we did right here, but also the magic of soil stratification. So I'll see you guys in a second. Okay, chaps, so we're back. We've moved across. I hope you guys can hear me kind of fine. Now, luckily during lockdown, we've eaten a lot of sushi, which means that I have a lot of free chopsticks. And free chopsticks mean only one thing to an ESS student, and that's corner markers. We start off by marking the corners of our space. Now, what do we need to do that? We need a measuring device. I'm going to lay mine out here. Let's take it. I overestimated my space, I'm afraid, guys. With 5 meters, well, maybe a spot less, maybe 4 meters wide. So, one corner marker, another corner marker. Let's make it a square. You guys will get nicer. We'll take measures in this. Nice fabric one. Another one. Right here. So we've marked our space. For those of you who are working in woodland, it might be nice just to put yourself a little loop into the string, and one. Wrap it around, doesn't need to be super tight. Really ever need to be for that matter. And if only I had enough string to complete the circle, square, I guess. But I apparently don't. That's okay. Now, I have my area marked out, and as we said, we should have a list of 25 coordinates for this. Now, Let's give it a go. Since I've halved my space, I'm going to halve my intervals. Let's say that my first space is 1.5 meters across and 1 meter up. I go 1.5, or you can measure it or you can pace it, it's up to you. And 1 up. I insert my soil moisture probe into the ground and I read it off, and it tells me 4.2 for argument's sake. Now, what's important when I'm measuring my soil moisture is that I mark a little dot. Anything that you dip in or stick it in, you need to mark a line on so that you always dip it or stick it in exactly the right way. Okay, whether it's a pH probe or whether it's a moisture probe. Now, the rest is straightforward, right? All that I need to do is I need to go to my different coordinates, stab my measuring probe in exactly the same amount so that I'm measuring exactly the same depth under the soil surface. When you come to the next activity today, you're going to see why that's important, because the soil has distinct layers and those layers have different properties. We want to be measuring the A horizon, so not the O horizon, which is the organic matter layer on top, but we want to be measuring the A horizon, the very first level of the soil. That's what's most important for us. Now, naturally, I would do this first in my lawn with 25 locations, and then in my flower bed with 25 locations, and I would work through as is shown. I'm going to stop recording and we're going to move on to the next technique. Okay, so chaps, on to technique number 2. You'll notice that we flip back and we're at the Transect page. We're measuring the impact of the hedge on soil moisture or soil pH. It doesn't much matter, but arbitrarily we're going to say soil moisture again. Just keep things nice and simple. Now, again, it's a moment to start off by measuring. So, I take my measuring tape and I pick the location of my first transect. Now, this is something that's really important. If I measure a transect from here, come under the box, away from the hedge, all the way across to here, then it lands me at the base of the tree. Now, if I cover this entire distance, I'm measuring not only the zone of influence of the hedge, but I'm also measuring the zone of influence of the hibiscus tree, and I don't want that. So I have to very sensibly think about my distances. I'm going to put this one in here, and we're going to work out, and that works out great, because I have 2.5 meters, 2 meters, 1 meter. Let's have a look. I missed the chopstick. There we go. And 1.50 m. 1, 2, 3, 4, 5, 6. Oh, probably don't need this one. That speaks for itself. So let's put that at 50. Now, I have my points all marked out. Next thing to think about is how much data do I gather? Well, it's important to think about the reliability of each data point. Every point that you measure on the transect has to be a reliable number. Now, in order to make that a reliable number, we shouldn't only measure it one time, but we should measure it a couple more to check that we have numbers in agreement. So I'm going to go to my first data point. I'm at 2 meters. And I'll stab it in once and read it off. And I'll stab it in again, distance away, and read it off, and I'll stab it in again, a distance away, maybe on this side of the marker. If my 3 numbers agree with each other, then that's fine. I have 3 concurrent measurements. I put those down as measurement 1, measurement 2, measurement 3, and I'm done for 2 meters. I move on to 1.50 meters. Measurement 1, measurement 2, measurement 3. If it is that these 3 don't agree, I take measurement 4. do I have 4 measurements that agree with each other? If I don't, then I'm in a tie-break situation, so I take measurement 5. If they're all over the place, at 5 measurements, just take an average. Now, I've measured 2 metres, metre 50. I do the same for 1 metre, 50, and 0. At each measuring point, I've taken multiple measurements. Then, we take the whole thing, we move it maybe a metre to the right. We move our points up, and we repeat as we had. So, this is our second way of checking for influence, and this means of checking for influence allows us to see a by distance impact of a factor upon soil moisture. The next part of the video is the last part of the video, and in that part of the video we're going to measure the soil content. We're going to do something called a soil stratification test to see what different components make up our soil, so that we can compare the actual quality of the soil itself. Alright chaps, we're in for our last part. Well, this might have part B to be fair. We're going to have a look at soil stratification. So we've moved to the back part of the garden. There's some bare soil over my shoulder, and that's the soil that we're going to be sampling in the flower bed. Now, in essence, what we're going to do is we're going to make a great big mud cocktail, and we're going to let it separate out into the different layers that are present. Now, we're going to do this whole thing in a jam jar. This is not like posh science. We're basically going to put a known number of spoonfuls of soil into the jam jar. We're going to add to that a known volume of liquid, known volume of water. We're going to shake the whole thing up, we're going to let it settle out, and then with a ruler, we're going to measure the thickness of the different layers that come out. Now, if we were in school, we wouldn't do it into a jam jar, but instead we'd do it into a measuring cylinder. I only have one at home. I'm not going to put soil in it. So there you have it. Jam jar it is. Also, it'll do in a pinch. Out of preference, pick one that's a bit taller and a bit thinner. This is in case everything goes apocalyptic and you end up doing your IA with whatever you can find at the Albert Heijn, which won't happen. Now, for starters, we take our jam jar, lovely drawing, and we add in a known volume of soil. So here I'm going to say 5 spoons of soil. Looking at that, I already know that that's too much. Let's make it 3. It doesn't really matter what the number is, so long as it's a variable that you control, so that it's the same between all tests, okay? And I'm going to brush any loose material off the top of the soil, and I'm going to take 3 spoonfuls in a nice narrow hole. 1, 2, 3, huts, in they go. Okay? To that, I'm going to add 100 millilitres of water. Again, pick a sensible volume. I reckon this is like 250 millilitres. If you don't know how much it is, either look at the label, unless you've dishwashed it away, or fill it with water and record the mass before and after. It's the same as the volume. Or fill it with water and then pour it out into a measuring cylinder a few times and add up how much is in it. It's not a wild idea. Okay, so first your soil is in the bottom, and then over the top your water comes. Then we're going to put a lid onto the whole thing. We're going to shake it about like a Polaroid picture, but harder. And then we're going to allow it to settle. And what we want to see when it's settled is the following. We will get kind of a layer of floaty stuff on the top, okay? That layer of floaty stuff is the organic matter that floats. Then we will have kind of like clear water if we've left it for long enough. Then we may have some kind of swollen organic matter left on the top, okay? Like, I don't know, leaves or something, like that have absorbed water and sunk, but they're still clearly organic matter. And then the interesting bit, the particulate parts of the soil will have settled out according to particle size. So any stones will be at the bottom. Then the next thing up, the next distinct layer, is going to be sand, probably surrounding the stones. And then the layer after that is going to be silt. And the layer after that is going to be clay. Now what's useful about this is that if you know the proportions of sand, silt and clay, you can work out your soil type. This is going to be something that you're looking at in the second half of today's lesson, is using the soil triangle to work out the type of soil that's present. Now, let's quit fussing around and let's take a sample. I'm not going to go through sampling strategies this time because it's exactly the same as it was before. I'm going to point you a spot further this way and we can get going. Now, it's exactly in the way. I guess I could have anticipated that. Now, over we come. The first thing that we're going to do, is it this way? Yeah, it is this way. There we go. Is I can unlid this and brushing aside. So, for instance, got a bit of snail shell here. Whoops, we don't want that. I'll take 1, 2. Very good. 3. There we go. I'm going to take one from the back of the bed because I know the soil is different there. Right in, and I'm going to go 1, 2, and 3. There we go. So, I've got my 2 soil samples. The next thing to do is to put my known mass of water in. So I'm going to put 100 millilitres. Into my first one. Now you guys can see that's like, it's 2/3 filled that's perfect. Maybe I can angle you down a spot so you can see. I'm going to put my second known mass of water in. And again, over we go. So what do? We lid our jar, and after we've lidded it, we're going to give it a minute to soak. Just a brief moment. I wish I could remember whether or not that had a lid on it, but we'll go through shaking techniques, just imagining that it didn't. Somehow forgotten about it. Now, this is good. We take it and away from our bodies, right? Don't shake it next to your ear or something, because if it opens, you'll just cover yourself in mud. And we're going to give it a really big shake, like we mean it. We want all of the particles in there to absorb any water that they can. And we want them to be as mixed as they can be. And we're going to leave it separate. Next up, this one. Problem, no lid. What do? With the flat palm, we close the top of it, and we do the same. I'm going to stand up for this. Oh, thank goodness for that. I found the lid. Happy Christmas. No dirty hands for me. And here we go. We're going to give it a monster shake. And there we go. Now maybe it's nice for you guys to see, but if you have a look at this, you might, you can't. I'll upload a photo of this later, but you can already see that there's a distinct layer of sand forming at the bottom. Maybe if I, that's upside down, that's going to look weird. No. We'll let that stand. Now, we've done what we need to do. You guys have had an insight into 3 different sampling techniques, or 3 different things to measure about soil. I guess 4 really, because you could measure the organic matter content as a standalone thing. Significant. You can measure its moisture, you can measure the pH level in the soil. And you can stratify it to look at the percentage of sand, silt and clay in order to find out the exact soil type. If we think about sampling techniques, then you can apply these measurements either across a transect, where you check out how your value changes with the distance from an interfering factor, like a hedge or a road or whatever it might be. Maybe a sort of a frequently trafficked space, like a picnic table in a public space, or you can compare 2 random areas, like we might have compared the lawn to the flower bed at the back of the garden. Now, chaps, you will find the outcomes of this stratification photographed and sent on. Let's have one last go. That's a shame that you guys can't see it better. Whatever. And that's enough from me. I'm going to imagine this has probably taken like the first period. So take a short break, refresh your eyes by going outside, or at least looking out of a window. Maybe shout at some passers-by, nothing rude. And come back for 45 minutes of work. Goodbye, chaps.